Good morning and welcome. Today I'm going to go over the use of the Sensormedics 3100B oscillator on the adult patient. My purpose here is just to review the equipment with you so you understand what the knobs are, what they do, cover a little bit about the circuit, look at the blender, and finally the humidifier. Okay, here's the face of the 3100B with some of the labels on it. The first thing you're going to do when you set this up is set the bias flow circled here. Now, Pilbeam and Cairo's book on mechanical ventilation said the bias flow should be set between 25 and 40 liters a minute, for example, 30 liters a minute. And your bias flow is important when you're setting your mean, because if your flow is not high enough, you won't be able to achieve your mean pressure. I'll just add about the flow that if your flow is too high, you could create auto peep. A flow too low, and you might have difficulty removing CO2 from the circuit. So setting the flow appropriately for the patient is important. Okay, now you're going to set your mean. With a stopper in the end of your circuit, you will dial in your mean, shown the knob and where you'll see it. Now initially your mean is set 3 to 5 centimeters of water above the observed mean on conventional ventilation. A typical starting range would be 25 to 30. Your max is somewhere between 45 and 60 according to Pilbeam's book. Another thing I want to point out is that there is not a peep level here, that the mean replaces the peep, and that it is more than a normal peep. The next setting you have on is the amplitude. You can see this, you'll turn this knob in the circle until you achieve the reading that you want. Some practitioners have set this amplitude reading or power at 20 above whatever their CO2, their last CO2 was. In high frequency ventilation, there really isn't a tidal volume and a rate. The amplitude would replace your tidal volume in that it's the power of the piston, and the rate would be your hertz. You see that circled here. Now, one point I want to make is that number one, for adults, that the frequency is typically in the range of anywhere from 3 to 7 hertz, but it works opposite than frequency would on a ventilator, in that as you turn hertz down, you have more area under the curve and could result in blowing more CO2 off. So really you can blow more CO2 off by turning the hertz down. That's opposite of what you would see in mechanical traditional volume ventilation. Now you see circled are your only alarms for the oscillator. This is an alarm based on the mean pressure, and these are set plus or minus 5 based on what mean that you currently have. In other words, if the mean rises more than 5 above what you're set, then it'll automatically shut off. To get it restarted, you'll have to hit the start-stop green button to start the oscillator back up once the mean pressure is back in range. Shown here is the typical flexible circuit for the oscillator, and what you see is there are lines going to 3 mushroom caps that have to be functioning properly and be tight. They are red, green, and blue, and make sure they're in the appropriate spots as you see in the picture here. Also, high-frequency oscillatory ventilation must be humidified. The temperature for the humidifier is typically run between 34 and 37 degrees Celsius. The Fisher-Paykel shown in this picture will do that automatically. The FiO2 is set. It's hard to tell in this picture. I'll show you another. The blender, of course, is connected to both air and oxygen, is located on the bottom left of the oscillator, and is used to control your FiO2. Okay, let's talk about how to respond to blood gases. Now, before you get a blood gas, remember to set your delta P amps, or the power, to see the chest wiggle all the way down to the thigh. Once you have that achieved, and after 30 minutes or so you get a blood gas, just realize that your carbon dioxide is inversely proportional to your amps. In other words, if you want to lower CO2, you'll turn your amps up, and vice versa. The oxygen is controlled by your mean pressure, which was set initially 3 to 5 centimeters of water above the mean observed on conventional, and by your FiO2. Also worth mentioning is it's important to have a cuff leak. Turn the mean pressure up by 5, then remove air from the cuff until not only do you hear a cuff leak, but the mean pressure returns to where it was prior to that. Finally, I want to mention just a couple of more things, and one is that Typically, at the beginning of oscillatory ventilation, a recruitment maneuver can be done, and you can read more about this in the Sensormedics 3100B Pocket Guide or in the book that I referenced earlier. Just be aware that a recruitment maneuver could lead to tension pneumothorax, and so you should be prepared for that possibility. Also, you should have the high-frequency guide Sensormedics 3100B Operator's Manual handy, and you should be familiar with it.